Today we are going to be doing lessons 6.3 and 6.4, multiplying monomials and then multiplying monomials by polynomials. So let's look at notes for 6.3. So we've done adding and subtracting, and when you add and subtract, you can only add or subtract coefficients that have the same variable raised to the same exponent. Multiplying, though, is different, okay? So when you multiply the same bases by exponents, you will add the exponents. So now we're adding the exponents together. So look at this problem right here, this example. You have 7a squared times 3a to the fourth. The first thing that you want to do is you want to multiply your coefficients. So 7 and 3 are my coefficients. I want to multiply 7 times 3. That's the first thing I want to do. Then I'm going to add up my exponents. So this is a to the second plus the fourth, because I have 2 and 4 right here to the same variable. All right. So that is what we're doing. Hold on. So then when we combine this, we do 7 times 3 is 21. A to the second times a to the fourth is a to the sixth. And that would be our final answer. Okay, so take a minute to look at that. If you're moving ahead, wait until I get there.
Yeah, example 1 and 3 are the same. Yeah.
Oh, I forgot to change number 3. That's right. So what we can just, I mean, we all know what number 3 is.
You want to change up the answer in the question?
No, it's okay. All right. Yes.
If it's like a negative a to the fifth, would the exponent also be a -5, or would it just stay as a?
It would just stay as a 5. The negative is the coefficient of 1. So it'd be -1, a to the fifth. So in this case, we really don't have any coefficients, but we do have a negative. So our final answer will be negative. Yes.
So the coefficient is, so there's going to be a negative coefficient.
So the way that you could write it is like this: -1, because there's a coefficient. And now we're going to combine our a's. We have a to the fifth plus a to the second, or times a to the second. Then we have b to the power of 4 plus the power of what? What 1, right? Because that exponent is 1. So our final answer will be negative a to the 7th, b to the 5th.
Wouldn't it be 6 because it's 5 and 2? Right?
5 plus 2
Yeah.
is 7.
Oh my gosh, I see.
Okay, any questions on those examples right there? We're just multiplying a monomial by a monomial there. Yes.
Are you recording?
Yes, I am.
Okay.
Okay, let's move down to the next section here. Now we have powers raised to powers. And when you raise a power, that means you're going to multiply your exponents. Okay. So in this case, we have 3 to the power of 2 raised to the power of 4. And the way that that works is we take 3 to the power of 2 times the power of 4. And so our answer would be 3 to the power of 8. And no, we're not going to multiply 3 8 times here.
Oh, thank you.
Okay.
Is there any, like, are we ever gonna have to do that?
No, I can't see, wait, what does that say? I know it says, it has the 3 right there, but
It's an 8, little 8.
yeah, but those are prescriptions.
Does that help you?
Okay, moving on. I want everybody to do example 5. When you have it, check up on the screen, see if you've got the right answer.
12's a little hard.
Okay, we'll get there in just a second. Okay, for examples 6 and 7, it's the same thing, it's just variables instead of numbers. So for 6, we have x to the power of 4 times 7, which gives us x to the power of 28. So looking at example 7, what's our answer there?
45.
Yeah, x to the power of 45.
Okay, it's actually
Just one.
understand it.
Yes.
Actually, you're about to do it. It's-
So why -12?
Well, yes, this one is going to be, so -1 times y to the power of 4 times 3. So it's -1 y to the power of 12, but do we need that negative, or do we need the 1 there? No, so we could just write it as -y to the power of 12.
So it's not -12, just 12.
No, 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 that negative is in front of the coefficient, not the exponent. I believe dividing, we deal with negatives, but we'll deal with that later.
Can you remind me what a coefficient is again?
It's the number in front of the variable, the number in front of the letter. All right, so what's the answer to number 9?
Negative a to the 16.
Thank you. All right, now, looking at number 10, we have an exponent with multiple terms on the inside. And so this exponent is going to be applied to every single term. So it's going to be applied to the 2. So we have 2 to the power of 3. It's going to be applied to the x squared. So we have x to the power of 2 times 3. And then it's also going to be applied to the y to the power of 4 times
What about
3.
4?
I just did that one. So I need you to look at this and I need you to process it and make sure you understand how to apply a power outside of the parentheses to every term on the inside.
Wait,
Hold on.
So
Why'd you
if
do
we
it to
didn't give a
two? Why'd you do it to
coefficient,
two?
exponent,
Because the exponent applies to every term on the inside, including the coefficient.
Isaiah
So the
had
2 is like
chat.
separated from the base.
but like
in a way.
on number 4, the number is there, but you kept it the same.
Because 3 already has an exponent. So we just combined the exponents.
Oh,
If 3 didn't have an exponent, then yes, we would have had to apply it to the 3 as well. But we did apply it to the 3 because we applied it to the exponent that belonged to the 3. It's just this 2 doesn't have an exponent. It's like 1. So
Oh,
it could
it's
be
not
2 to the
two.
power of 1 times 3. Does that make sense?
Yes.
yeah, it makes more sense.
All I did was I applied the exponent of 3 to the 2. So I made it 2 to the power of 3. So then here, the 2 and number 11 is just going to be applied to the 4. So it's going to be 4 to the power of 2. Okay,
This is-
So-
I'm sorry, this is kind of like distracting.
okay,
I'm
all right.
sorry.
Hold on just a second.
Oh, she stopped the share.
Okay.
Isaiah wanted to do it.
Press more. Press more.
Okay, so let's finish up example 10. So in a problem like this, you will need to multiply out your coefficient. So 2 times 2 times 2 is not 6, it's 8. So we have 8y to the power of 6, no, x to the power of 6, sorry, y to the power of 12.
Wait,
wait, where do we get the 8?
Isaiah wanted to do.
the
it.
2
times it by
2 cubed is 2 times 2 times 2.
Oh, okay, so
I'm
we
still
would,
confused.
so we would solve it, we wouldn't keep the exponent out.
Right.
Okay.
Wait, what?
Yeah.
I'm confused. Explain.
So
We
you
would-
see the 2
We would
cubes?
solve the cube.
But the-
Oh, where's the 2 cube?
Right there. The 2. And cube has a 3.
I see, I see.
The 3
Understand?
is applied to the 2, making it 2 cubed. The 3 is applied to the x squared, making x to the 6th. And the 3 is applied to the y 4th, making it y to the 12th.
Okay.
Okay, let's look at example 11. Danny,
Yes.
how am I going to apply the power of 2 to the 4? How will I write that? Yes.
Back on number 10, How did you get 8? Because 3 times 2 is 6.
2 times 2 times 2 is 6.
It's
Wait,
two
what?
times
3
three.
times 4.
Guys, let the teacher explain it.
Remember x, when it-
It's not 2 times 3, it's 2 times 2 times 2.
Because there are
2 times 2 is 4,
That's how you get
4
eight.
times 2 is 8.
You see that little thing she's.
Why did they do that? Why can't they just make it 3 times 2? Like, it doesn't make any sense.
That's not what 2 cubed means.
Yeah, I know, but. it
Okay.
doesn't have to be cubed.
Oh.
It can be what I want.
You know,
Right.
you know.
Okay. All right, so going back to number 11. Now, Danny, you're gonna finish this with me. How am I going to apply the power of 2 to x to the power of 4?
4x to the 4x, the power of 4 times 2.
Okay, ignore the 4, just the x. Tell me what to write with.
Oh, oopsie, sorry. X to the power of 4 times 2.
Yes. And then what about the y?
Y to the power of 7 times 2.
Yes. Now solve that, and when you're done, I want you to tell me what your final answer is.
Can I do number 12?
Yeah, how about someone else answers it?
Okay, go ahead, Eli.
Wait, I wasn't ready.
Wait, I can.
Go ahead, Bo.
Wait,
Oh,
no,
for
no.
like example 11.
Don't let him take it from me.
16x8 to the power of 8 and
Bruh.
y to the power of 8.
Yes.
What a nerd.
Eli.
I don't understand.
I was just like-
Help somebody.
I was.
They're not gonna cheat sheet.
Okay, so for example 12, this is, you need to make sure that when you work in algebra that you work from the inside out. It's part of the order of operations. You always have to do your exponents first. So we have brackets with this exponent of 4. Do you need to get your water? Okay, but on the inside, we have exponents that need to be applied to each term within their individual parentheses. So for example, this 2 needs to be applied to this x squared, and the 2 needs to be applied to the y. Then this 2 needs to be applied to the x and then to the y cubed. So I'm just going to pull all of this down and rewrite it. So I have in the bracket x to the power of 2 times 2, and then y to the power of 2. And the reason I have that is because I distributed this exponent of 2 to both of those terms. Now I'm going to do the same thing for this parenthesis. I have the exponent of 2 applied to x, which just gives me x squared, and the exponent of 2 applied to y cubed, which is y cubed times 2. Still within the bracket with an exponent of 4. Okay. Now what we have to do is we have to simplify these terms and then multiply them and then apply the power of 4. So x to the power of 2 times 2 is x to the power of 4y squared. And then in this next one, we have x squared, y to the power of 6, 4. All right, I'm going to stop for just a second to make sure everybody understands how I've gotten this far. You need to kind of try to process it. Make sure you understand it. Okay. Thank you, Mila. Bella. I did that.
She went Bella.
Okay,
Always works at us.
now I need to combine my y's and my x's inside the brackets. Okay, so remember when we multiply variables that are raised, well, when we multiply variables together, what are we doing with the exponents? Are we, what operation are we doing?
So you're multiplying the 6 and the 2 and the 2 and the 4 together?
No. No. So I want to combine x to the 4th and x squared. How am I going to do that? You said 6.
Well, I said 6 to the 2, like,
Oh, here and here. Oh, you were
Yes.
moving backwards.
Times
Yeah.
The outside bracket, the 4, and then times it on the X.
Not yet, though. I mean,
Not yet?
I have to
Oh.
finish what's on the inside. So when I combine x to the 4th and x squared and then y to the second and y to the sixth. Okay,
You get 2x to the 8.
how do I get this right here? What is the answer to 4x, x to the fourth, x to the second times x to the second?
But when you add.
Yeah.
You add them.
X,
That goes all the way back up here. We added our exponents.
Yes, sir.
Okay,
So it's 2x to the 8.
so this becomes
2x to the 8.
x to the power of 6, y to the power of 8.
Wait.
Because you have to, when you multiply with exponents,
I see.
you add those exponents.
It makes sense.
Yes.
Is
Oh, never mind.
if you multiply for.
If you do the, if you apply the 4 first.
And then you combine them.
That's what I did. I did the 4 first and then I combined them, but I got like way off. I got like in the hundreds.
Yes,
You could?
yeah, you could. All right, and now we're gonna finish this off. We have x to the power of 6 times 4, y to the power of 8 times 4. And now our final answer is x to the power of 24, y to the power of 32. So that was a really, really long problem. Okay. All right, and that concludes lesson 6.3.